Okay, so let's pick up where we left off then, and let's start looking at which words we need to do clarification on. Okay, so what are some of them, guys? Just let me know what they are here, and I'll kind of underline or whatever. Semi-permeable down here, right? Okay. All right. Semi-permeable membrane. Semi-permeable means that only some things get through. If something is completely permeable, that means everything gets through it. So a plant's cell wall is permeable. Anything can get through. There's no selectivity, there's no filter or anything like that. But your cell membrane is semi-permeable. Some stuff gets through, some stuff doesn't. Okay? We also sometimes call it selectively permeable, right? Because it can actually select what gets through. Okay, what else? Other words, guys, that gave us trouble. Eli. Well, I'm going to go over the ones that are already highlighted. I wanted to go over the ones that maybe gave people trouble, that gave you guys trouble, other than the ones I kind of thought would. Okay, I wanted to go over any other ones that might have given you trouble. Danny. Fluorosis. Okay, fluorosis has to do with bone structure and teeth, and if you don't get enough certain of minerals, then you'll get deformed teeth and bones. Okay, kind of like rickets. If you've ever seen someone with rickets, generally they get kind of bow-legged and stuff because their bones get weak. They don't have enough calcium in them, and then yeah. Equilibrium. If something is in equilibrium, that means movement in both ways is equal or balanced. So a state of equilibrium means everything is balanced. There isn't a net movement one way or the other. Okay, so when we're talking about osmosis, osmosis is trying to achieve a state of equilibrium in terms of salt concentrations on both sides of the membrane. Okay, once it reaches that equilibrium, water stops moving. Okay, right, other words. Hunter? No? Okay, well, if more come up, you can ask. I'm going to go over the ones I thought would give people trouble. Okay, desalinization. Okay, desalinization means the removal of salt. There's a number of ways to do that. The most common way is through reverse osmosis because it's the cheapest. But in some cases, there's actually a distillation that goes on. Distillation means that you boil off the water to leave all the salts behind, and then you recondense the water. It is a very energy intensive process, so it isn't generally used on a large scale. Okay, unprecedented. Unprecedented means that nothing like this has happened before. Okay, this sets a precedent. Okay, it means it's like a record-setting thing, or it's the biggest, like Hurricane Patricia right now in Mexico. Okay, is an unprecedented hurricane. It is the biggest hurricane on modern record. All right, it is absolutely enormous. Well, but unprecedented sounds cooler. It doesn't necessarily mean that it's record-breaking. It could be record-breaking. Unprecedented means nothing like this has ever happened before. Yeah. Hey, Ashley, you had a question? It'll be weighted the same as anything else. Yeah. Okay. I mean, the number that something is out of isn't necessarily what it counts for in terms of your grades. I try and make all the assignments worth about the same amount weight-wise. Okay. Okay. Torrential. Another one that I thought people might have trouble with. A torrent is like a current or like a river or a stream. So if something is torrential, that means it's really moving. Okay, it's really running. So the floods that we had there in 2013, those were torrential. Okay, we had torrential rain, we had torrential runoff. Okay, it was just everywhere, and it couldn't be contained within the normal barriers of the rivers and streams, so they were out over the flood walls and stuff. Okay. Other ones here. Whoop. I'll put that away first. And that's not the way I want to do it, doofus. Okay, what was the other one here? Osmotic pressure, that was another one. Okay, we talked a little bit about that when we talked about how plants move water. Osmotic pressure is pressure that is created by an imbalance of salt. So if I have more salts on one side of a membrane than another, there's a pressure that essentially forces the water through the membrane, okay, or causes the water to move through the membrane in order to balance the salt. So osmotic pressure is what causes water to move up a plant, okay, or across a membrane under natural osmosis conditions. Okay, concentrate. It doesn't mean this kind of concentrate with your brain, okay? It means to make something, I can't use the same word in the definition, to make more of it in the same space. So if I was making Kool-Aid and I make Kool-Aid normally, it would have a certain concentration. If I poured twice as much sugar and twice as much of the Kool-Aid packet in there, I would have twice as much. I would have more, it'd be more concentrated. Same volume, but I have way more stuff in there. So now it's more concentrated. Everybody follow me there? Okay. The other example would be the vinegar you buy in the store is 5%. It's concentrated at 5% acetic acid, and then the acetic acid we used in the lab was like 80%. Okay, it was way more concentrated. There was more acetic acid in it than there was in the other. Okay, bars of pressure. Okay, bars is a unit for pressure. Okay, with kilobars or millibars or whatever. Okay, it's a unit for pressure. It's actually an imperial unit. In metric, we use pascals as a unit of pressure. Right, so you may have heard, like on the weather, the atmospheric pressure is 101.1 kilopascals. Okay, that's the pressure of the atmosphere. So it's pascals and bars are a unit of pressure. If you pressurize something, the number of bars is going to go up. Okay. If you're not in French, that's voila. Okay, and it means there you go, or there it is, or something like that. Okay. Okay, so desalinate, we already talked about. Okay, remember I told you last week that you want to look for things that had to do with the questions. Okay, there was a little thing in there about wine and things like that, and syrup. Okay, impediment. If someone has a speech impediment, what do they have trouble doing? Yeah, speaking. You have something that is impeding or slowing or altering or is somehow a blockage to their speech. Okay, so if something is an impediment, it is a barrier or a blockage to doing something. All right, so if we're talking the biggest impediment of reverse osmosis, this is the biggest drawback or the biggest barrier or whatever to reverse osmosis. Okay, WHO and UNICEF. WHO stands for World Health Organization. Okay, they're the people that make sure that there's, kind of like healthy drinking water. They make sure that there aren't outbreaks of certain diseases, and if there are in areas, they try and go in and contain it so that it doesn't spread. Okay, that's kind of their job, is, well, to keep an eye on the health of the world's population, not the world's environment. Okay, UNICEF. United Nations International Children's Emergency Fund is what UNICEF stands for. It's money for children. All right. If you were maybe when you were a kid, you had the little UNICEF things. You donate to UNICEF. That's quite a while ago. You used to go around and collect pennies for UNICEF. It's the United Nations, essentially money to take care of children in areas struck by emergencies. They will be in Mexico this week. Okay, they'll be taking care of civilian population, making sure that they have clean drinking water, right? Because that is always a problem after a hurricane. Okay, salt water moves in and contaminates wells and drinking water supplies. Runoff runs over contaminated soil and it gets into the drinking water. So they'll be bringing in clean drinking water there. Okay, that'll be their job. And that's it. Any other ones that you guys wanted to go over? Hunter. Mm-hmm. Like 3 here, the question number 3? Yep. Well, then just says justify if you think. If you don't think it is, then you got to tell me why you don't think it is. Okay? All right, so if you think reverse osmosis is a way to conserve water, remember, say that was the key thing. Is it going to save water? It's not if it's going to clean the water. We know it's going to do that. Is it going to save water, conserve water over traditional methods? Okay? Tell me if you think that's true, why. If you don't think it's true, why. Okay? All right. Other questions? All right, so since I'm telling you that this is going to take you at least 45 minutes, okay, am I expecting a fair amount of writing for each question? Yes, I am. All right, so I'm not saying, I don't want to say, have for answer number 3, justify if you think using reverse osmosis would be an acceptable way to conserve water. No. And okay, if you write no, that's just not going to do a very good job. In fact, I might not even notice that you just wrote no because there'd be so little there. All right, so yeah, you got to explain your answers here. Use what's in here, use what's in here, okay, and get a good answer together for those. All right, and then when you're done that, you got some time to work on your cell anatomy lab as well. Okay, all right, let's get to her. Okay, so some ideas for kind of things to include in your answers here. For number 1, okay, you want to compare and contrast. So we want to look for similarities as well as differences. Okay, so similarities could be in what they do, right? A reverse osmosis membrane and a cell membrane do similar things. Okay, what do they do? That could be some of their comparing. Contrasting are things that are, how are they different? Okay, we know they do the same job, but okay, maybe they're made of different materials, and I believe that in the article it does mention a few materials that reverse osmosis membranes can be made out of. That would be something that would be different, okay? Things like that. So if you look through there, you can find a couple of those things that are different, okay? For number 2, okay, providing the force, okay, we've talked about the force that powers natural osmosis, okay? We've talked about that. But you do need to read through how do they use, or what force do they use for reverse, okay? It's probably artificial, because we know reverse osmosis is an artificial force, okay? So you can look at that and try and figure out from the article, okay, the things that are used there. And that's where that bars of pressure thing that we covered a few minutes ago, it's in that area, right? For number 3, okay, again, with your short paragraph there, you got to look in there and remember we went over the word impediment, okay? We went over that means something that is a stumbling block to something, okay? In that area is where we're going to find the if we think using, or if reverse osmosis is going to be useful in conserving water, okay, or not. It's going to be in that area there. And then lastly there, it was mentioned in the article that reverse osmosis removes the impurities. Michael asked, does this mean like, is a purist the same as someone who would be a connoisseur? And my answer to that would be, yeah, probably. Okay, a connoisseur is someone who wants to enjoy something for the sake of it and really knows a lot about how something should work, or how something in this case would taste, and then they would know what kind of differences would be present if something had been changed, and they might not like the change. They might want it the original way, right? So things that reverse osmosis would remove from those two materials would be bigger stuff, okay, sediments and solids, and how might that affect them? That's something you're going to want to cover in there, okay? So when you're reading back through that, remember we said we wanted to highlight things we thought fit with what we were covering, okay? Now you want to go back through and look at, okay, I said something about that, I highlighted that, it was Friday, what did I mean by that? You might have to read the whole paragraph again, okay? But that's what we're working on. We're trying to get those literacy skills kind of polished up, okay? Any questions thus far? Okay, keep going then.